Hi everyone, in this tutorial we are going to dive into QGIS and walk through a full workflow together from basic vector operations to map layout and exports. I'll show you different ways to select polygons and export selected features. You'll learn how to change vector symbology, clip vector layers with an AOI, and export multiple layers into a single GeoPackage. We'll also work with rasters. For example, we are going to clipping a raster with a vector, applying hillshade and slope, hiding pixels based on their values, and customizing raster symbology. On the analysis side, we are calculating polygon areas. We will measure line length, extract contours, and quickly identify and measure features directly on the map. Then we'll explore elevation data with the Profile Tool plugin, create topographic profiles, and display vector categories properly. Finally, we will move into map design, so we will creating a 2D map, styling it, adding geographic grids, inserting a topographic profile, exporting the final map, and even adding a photograph to your layout. So if you want to improve your QGIS skills and speed up your workflow and produce clean professional maps, you're in the right place. If you want to select only one polygon in this vector file, you click on the layer, you right click, and you go into the attribute table. You can open it. And here you can identify which field you are targeting. So here it is non officiel. This is the name of the municipality we want to select. So here you have the tool select features using an expression. So this is one way to do this. So you click on it, you go into fields and values, you double click on it, and here you have your target field. So it is non officiel. So you double click on it. This is the field that contains the entity you want to select. Here you can double click on equal operator. Oh, just one click is okay. Here you can display all unique entities. So if you click on it, you will see all the municipalities of France. So if you want to search for only one municipality, you can write the name of it. So the target entity is Bonneval-sur-Arc. So you can double click on it. And here you can select the feature. If you want to see the selected feature, you can click on Move Selection to top. You will see your entity that you want to select. If you want to zoom directly here, you can click on Zoom Map to the selected row or rows if you have many of it. And if you exit the attribute table, you will see that you have zoomed on your selected feature. So here, if you want to export it as a shapefile layer, you can go into the menu Export and you click on Save Selected Features or Feature As. You select the format in which you want to export your vector file. So we will keep the shapefile. Here you click here and you can select a folder, and you can write the name of your exported layer. You choose the CRS, so for France we will keep the Lambert 93 EPSG 2154, but if you need another one, you can click here and you can filter one geographic reference system. You can choose another one here. I will keep this one. So if you click OK and add saved file to map, you will see that your exported layer will be displayed here, and we have our vector file here. It is to know that you have many ways to export a vector file. You could have selected using this tool here directly in the interface of QGIS. So if you click like that, you will select many features or maybe one feature. Here you can deselect features from all layers. So one other easy way to export a vector layer is to click on it directly and to right click and to save selected feature as. This is the same way to do this. This plugin is really useful because it allows you to display Google Maps and many other tools. So you can go in the menu Plugins, you click on Manage and Install Plugins, and here you will write HCMGIS. You will find this plugin. Here you can install or upgrade the plugin, and you click on it and you close the window. And you will see this new menu, and here you can import many base maps. So I will choose Google Satellites for this tutorial. So if you want to change the symbology of this vector file, which represents the boundary of the municipality of Bonneval-sur-Arc in France, you right click on it or you double click on it. This window will appear. In the menu Symbology here, you can choose the single symbol if you have only one polygon. And here you can click on the simple fill, and here you can choose the fill color. You click on it and here you can adjust the color of your polygon. If you want that your polygon to be transparent, you can choose the opacity here. That's what I want for this tutorial, so I click on OK. You see that the opacity have been changed. If you want to have another fill style, here you can choose, for example, some vertical lines, or maybe, I don't know, diagonal lines. So I will keep solid and I will keep this opacity. If you want to change the stroke color, here you can of course choose another color. Here you have the stroke white, so if you want to increase the stroke white, you can click here, or if you want to write directly, you can choose dot lines, you can choose dash line, whatever. So I will choose dot line, and you can choose of course the joint style. If you want to add another symbol, you click here. You see that another symbol have been displayed here, so you see that you can mix many symbols to choose the one that you prefer. So you see that you can build complex symbology here. Then you can apply when it's finished for you, and you hit the button OK. Okay, I want to add some shapefile layers. I have my folder here. I just click on type. I search for this format, shapefile. I select those resources and I just import it into QGIS. Then what I want to do now is to group them in a new group of layers. So I click on group selected and I just write it. So now I want to cut them to keep only those that are located in Bonneval-sur-Arc. So one really easy way to do this is to click on your layer. You go into the menu Vector, you go into Geoprocessing Tools, and here you can select a clip. You have another way to do this is to go into Processing Toolbox, you click here. This Processing Toolbox window will appear and you will be able to choose those operations about vector. I recap. You go into the menu Vector, you go into the Processing Tools, and here you click on Clip. This window appears. You select the input layer that you want to cut with the other layers, and the overlay layer is our municipality boundary. Here you can open the advanced options. You can choose the default invalid feature filtering. You can choose to skip, ignore features with invalid geometries. I will keep those parameters, and you can do the same with the overlay layer. You can create a temporary layer, or if you want to save the exported file to a new file, you click here. I'm going to create a temporary layer. You can hit the button Run, and you see that a new temporary layer just appeared. And you see that those which are located into Bonneval-sur-Arc have been selected and exported. They basically have been cut. Now, if I want to create a new GeoPackage layer with all of those features that are clipped with the Bonneval-sur-Arc boundaries, what I have to do here with our first layer is to right click on it, to go into Export and Features As, and here we choose GeoPackage here. In the field name we will name our GeoPackage layer, so I will choose this name, Hydrology, and here I can rename this layer. So you see that this is exported with the layer options, so those are points. So you can click OK on it, and you see that those layers have been exported into the GeoPackage Hydrology. So I can remove this temporary layer. I can remove this layer too, because these have been exported. So I can do this with all of those layers. We will see in another tutorial how to automate in this workflow, so if you have to repeat the same vector operation, so here this is the cut operation about two vectors layers. This is an intermediate workflow, automating workflow to do to automate this task. So you have the second layer, you export features as, and you choose the same GeoPackage here, and here you rename it, so hydrologic, and so on. So the first thing will be to import our raster layer, which is our DEM, the digital elevation model. So you can add this raster layer and you can close it. You see that your raster layer has been imported. So if you want to clip this raster with a vector file, you click on your raster layer, you go into raster extraction. You can clip raster by extent, you will clip your raster with your current window. But if you clip raster by mask layer, you will be able to choose a mask layer. So this layer will be Bonneval-sur-Arc, the boundary of this municipality. Of course, you set the CRS. Here you can create an output alpha band, but so that's what I wanted to do. And you can save the clipped raster layer into a new file. So I will call it DEM 1 meter. I choose the TIFF format for this tutorial and I can save my new layer. You run the algorithm. Once it's completed, you can close this window and you can remove the previous layer. So let's see together some operation on raster. Here you go in the menu raster. In the menu analysis, you can process many operations with GDAL. So for example, the hill shading, you click on this menu. You choose the band number. So the band 2 is the transparent band, so you choose the band 1. You set the Z factor, so for this tutorial we will choose 2 vertical exaggeration, and you can choose the azimuth of the light. So you can choose this formula instead of the Hans ones, but this is a topographical sector with very high altitude, so we will keep this one. You can save this new file. You rename your raster and you can save this file. So you have the hillshade version of your raster. You see that now you can have a better understanding of the micro topography, which can be very useful in geomorphological analysis. Another useful trick, if you want to hide some pixels, some value of pixels, you can go into the menu transparency and you can apply some transparency for those pixels who are equal to 180 to 182. So you can choose to calculate, for example, the slope of your raster with the algorithm of GDAL. So here you can, of course, you still select your band 1. We will keep it in degrees. You go into Save to File, and here you will have the slope of your raster of your study area. So you have a new raster with slope values So if you want to change the symbology of it, here you can choose in the menu symbology, you can choose the band rendering. So if you select the single band pseudo color, you will see that you can choose, of course, the min and max values. So we will set 100 for 100 degrees. Here you can choose if you want to have a continuous interval or equal interval. So if you choose equal interval, you will be able to set the classes. So we will keep 5 classes. And here in color ramp, if you click on it, you will be able to modify your current color ramp. But if you go into this little arrow, you will be able to select another color ramps or maybe create new color ramp. If you choose the CPT-CT color ramps catalog, you will have many ramps. So if I choose topography, you will see some color ramps that are really interesting to display topographical features. So of course you can create a new color ramp. So for example, I choose this one, and here I can apply many colors. So if I want to choose the color of my features, I can do it like that. And here you can make OK, and you will be able to display your DEM with the color you want. If you are fine with one color ramp, you can export it. So you go into properties, you go into your menu symbology, and here in the menu style you can save this style. It will generate a QML file, so you can save it. For example, I don't know, slope, and you can save it like that. In this way you will be able to apply this style. You will be able to apply this style directly by loading this style. You select this QGIS layer setting file, you load this style, and you apply OK. You have your slope with the same symbology. Now we are going to calculate the area of our municipality. So you right click on your vector layer, you go into open attribute table. Here you can hit the button toggle editing mode, and we will create a new field with the field calculator. Click on this icon. Here you click on create a new field, you choose a name. Here you choose decimal number, real, and you write $area. If you want to have it in hectare, you apply this expression. If you want to have square kilometers, you can create a new field and you choose this expression. Great, you see the preview here. You can apply and you see your area in square kilometers. You save it and you exit the editing mode. You can close it. For this step, we will select the arc river. So we go into the attribute table and we will choose the arc segment. So I will select the toponym and we select l'arc. Two features have been selected. We can skip, we can close this window and we will export the selected features. We will import in this GeoPackage layer. So I will call it l'arc. Okay. Here it is. If you want to calculate the length of this segment, you go into Open Attribute Table, and here you can toggle the editing mode. You open the field calculator, and we will create a new field. We calculate the length in decimal number, and we choose this expression, length. You apply, you will see that you have the length of this river. You save the edits and you can exit the editing mode. Okay, now so we are going to extract contour lines from our DEM. So you go in the menu Raster, and here you can extract contour. Here you set the input layer, that is our DEM. You select your bond number, and here you choose the interval between the contour lines. So we are going to set 5 meters. You choose the name of the target field for the attribute name. So elevation is okay. We set the offset at 0, it's okay with us. And you can save our contour layers to new files. And you can run the process. Once the algorithm contour finished, you can close this window. You see that your contour lines have been well created, so you can change the symbology. So I will set very thin strokes. And now we will apply new symbology. So we will load the previous style. This was for the slope. I don't know if it's okay. Nope. And so we create a new style. Great. This map begins to be more interesting. So I will play with the transparency, for example. You see that here, for example, you can increase or decrease the gamma. So I will decrease it. Okay, I'm fine with this. So the icon is here. You have to click on the layer you want to identify before, and here you can have the detail of the feature you have selected. So here you see that we have a glacier. For example, if you zoom here, you have écoulement naturel. This is a feature related to the river. So this is a useful trick. Here you have a like, so you can quickly identify some vector features, of course. But you see, if you click on other feature, you can't display the window. You have to select the layer before. By the way, you can measure area, so you can measure line, measure area, measure bearing. So if you want to know the distance between 2 points or maybe several points, you could do this. So here you see that you can choose your unit. So this is how we do. For the area, you can apply this like that. This is for fast identification or fast, and you right click to finish the polygon, and here if you want square kilometers, I don't know. That's how we do. Another useful trick is in the plugin profile tools. So it's a plugin that can plot profile lines from raster layers or point vector layer with elevation fields. So you can install this plugin, and then you will be able to select terrain profile here, and you can by clicking on your raster layer, you will be able to calculate profile very quickly. So for example, you right click to finish and you add the layer here. You will have your topographic profile. You can reset the view. You have the table here with multiple points. What's really interesting here is that you can save your PNG. But you could export it in a CSV table here. So this is a really easy and quick tool to display the topography here. For example, you can open the attribute table here, and you will see that you have the waterfall or maybe the springs, the watershed springs. So if you want to display those features by category, you right click on the vector, you go into properties. Here you choose the categorized symbology, and here you will choose nature. You can classify it, and you can change the symbol of each point. So for the waterfall, we will select a new marker. So I don't know, we will select this one. So I'm fine with this. I will choose to hide it for the glacier, for the lake too. And for the springs, we will select another symbol. This one. And you can apply this style. Now if you want to print a map with this extent, you go into Project, you create a new print layout, you enter the name of your map, you click OK. So here you can right click and go into Page Properties. Here you will have the layouts, the item properties and the guides. Also in item properties you will have the size of your map, so you can choose the format. Here you can change the orientation of your map, so I will select landscape for example, but you could take portrait format. So here you see the items, so if you want to add the map, you click on this icon and you can display your map. You see that this item just appeared. If you want to add the scale bar, you click here, you click on your item and you make OK. So you can choose another style if you want to have the single box, double box, whatever. I will choose the double box. You can select the scale bar units, so if you want to change it, you can do it here, and so you will be able to change the label for units. So I will keep it in meters. Of course, you can add some segments if you need. You can fit segments wide if you want to. So I will choose this one. Be aware that the scale bar is above the map, so you can change the appearance of your map, so you will be able to increase the box margin, you will be able to increase the label margin, so I will keep it like that. You can change the font, so if you want to change the type of your fonts, you can for example like this one. You can change the size too, you can change the color. Here you can add a buffer if you want, so you have many properties about it. If you want to explore it, you can do this. So here you can of course add a rotation on it, so if you want to change the orientation of your map, you could do this. If you want to add north arrow, you can click here and you can drop it. So I often choose this one, so it's like you want. That's here. Of course you can add a legend, so here you have your legend that just appeared, so you can add a title. Here you have the legend, so if you do this you will be able to modify your legend. so I will keep the DEM. You see that it just changed. Here you can remove the selected features, selected items. So for example, I will keep this one. You see how it works. We will remove the slope. Here, hydrology. So you see how it works. It is just for the example. So what it's really important here is that you can change the font and text formatting. So you can align the front title, for example. You can choose to display many columns if you want. Of course, you can change the size of your symbol. You can change the spacing between your features. So, for example, the symbol label space. You have the space between symbol too, if you want to make it more compact also. And of course you have the background color that you can change if you want to. The default color is white, so if you want to apply a transparency, you can. So you go into grid. Here you add a new grid, and here you modify your grid. You can choose a solid grid, you can choose to use cross or markers, or you can choose a frame and annotations only. So it depends on your coordinate reference system. So for example, I use the French one, so maybe I don't know. Yes, this is in meters en Lambert 93, and you will have to adjust your X and Y to have a good grid projection. So I will choose a zebra because I like this kind of representation, but you could use exterior ticks to have those little ticks with exterior. You can combine two grids, for example, so if you go back here you will be able to add a new grid. So you can modify this new grid, so you will adjust your grids, and here you can choose zebra, so you have the two grids superposed. So if I want to change the grid type, that's here, I can choose solid, or maybe this one, frame and annotation only. So you have to modify the two grids, so that's here. Oops, sorry. I don't know, I think I will choose a solid one, but I will change the symbology all of the line. So I will keep a very thin stroke white. So now what you have to do is to set the frame. And draw the coordinates. So you click on it, you see the coordinates have just appeared. So you can choose a decimal with a suffix, for example. You can custom it, but I will only keep decimal because it's okay for this example. So you can choose to put it inside or maybe outside. You can choose vertical ascending for the left, and for the right you can show vertical descending. You choose what you want to set. So here I will just keep this precision. You can set the distance to map frame. So this is fine for me. So you see how it can be done very quickly. So you need a QGIS version 3.34 at least to work with this tool. You will find it in the menu view, elevation profile. Here you see this new window that have been displayed here. There is many ways to create an elevation profile using this tool. Here you can add layers, so you can choose your DEM here. You click on OK. So you see this DEM. And now you can capture curve. So here in the interface you will have to draw your transect, and you can right click to make OK. So if you want to make another profile, you can display another elevation profile here. You will be able to combine multiple elevation profile. So now if you want to export this as an image, you can do this. But what is interesting is that you could add this profile here directly on your map. So here you can copy from profile here, and you choose the elevation profile number 2. You see your profile. So you see the profile curve. You have a tolerance that you can change if you want. You have the minimum distance. So basically we are going to draw this profile. So you can add the profile here. Approximately. So I don't know. I will do it like that. Okay, and I will adjust. So here you could modify the minimum elevation, for example. So I will. So it's okay. You will see this. And if it's fine, of course you can choose the units in the major interval, for example, the minor interval, for example, too. You could change the front of the label and so on. You can modify the background if you want, and the border too. I'm fine with this. I will add a text layer, so you can write, for example, elevation profile number 1, I don't know, it's just for the tutorial. Here you can change the appearance, the front appearance, so if I want, for example, I don't know, Arial, to do it like that, so after, so you can make it like that. You can choose whatever you want. It's just here you could copy and paste, for example. You see how it works. So you could make really beautiful maps. You will have to report it here. It's just a quick example here. So if you want to export this map, you go in the menu Layout, and you can export as an image. Here you can choose the PNG formats or the JPEG formats, whatever you want. So we will export it in PNG. Here you can crop to content and you can modify the resolution. If I want a good resolution, I can save this map. Okay, you see the export layout have been successfully done. One last thing, you could have had a picture of it. So here you can draw the picture, and here in the item properties you could choose a raster image. So here you can browse an image, for example, and you will be able to add this image to your map. That's it for this tutorial. We've explored together QGIS tools for vector and raster analysis, visualization and map creation. I hope this was helpful for your projects. Thanks for watching and see you in the next video.